Alright, welcome to yet another video still on electric field. So let's look at some calculation on the electric field. Don't forget to watch the previous video on electric field so that you understand the concept of electric field. And do not forget to like, share, and subscribe. Thank you. So let's take example 2. Let's read. An electron of this charge. So we have a charge which is Q to be 1.6 times 10 raised to the power minus 19 coulombs. Is situated in a uniform electric field of electrical intensity. So we are given electrical intensity E to be 120,000 volts per meter. That's a find the force on it, F. And you know, remember that I told you that beautiful way to write this thing, right? F is equals to QE. So what is Q? Q is 1.6 times 10 raised to the power minus 19, and E is 120,000. So if we press our calculator, we should be having 120,000. We'll be having 1.92 times 10 raised to the power minus 14 Newton. Easy, right? Yeah. The next one, find the acceleration. Hope you have not forgotten that according to Newton's law, F is equals to ma. So because we're looking for acceleration, A becomes what? F over m. So our force from here, 1.92 times 10 raised to the power minus 14. Do not forget, what is the mass of the electron? You know, the mass of the electron is a constant value, right? Which is what? 9.11 times 10 raised to the power minus 31. So our A becomes what? So we are having 2.1 times 10 raised to the power 16 meter per second squared. So the next thing to calculate is now the distance. Okay, because we are starting from rest, Newton law now, U is equals to 0, Abi. You know your A to be 2.1 times 10 raised to the power 16 meter per second square from this calculation. You know your distance S from your question to be 20 millimeters, but it must be in meters. You divide by 1,000, right? And then you are looking for time T. Now look at this parameter. You are saying something like equation of uniformly accelerated motion. Is it not true? And basically there are 4 equations, but based on our parameters is what? S equals ut plus half at squared. And you will notice u becomes 0, so this term cancels out. So I have S is 1 over 2 at squared. It is reasonable to make what you are looking for subject, so you can press your calculator once. So if you make this subject of formula, hope we are intelligent students and we can make subject, right? So if I substitute my values once, I have 2 times S 0.02 over A 2.1, right? Times 10 raised to power 16. So if I press my calculator, I should have my final answer. So I have 1.38 times 10 raised to power minus 9 seconds. So that's how it works. It's basically based on equation of uniformly accelerated motion. Now let's take the second one. Now for the second one now. We want to do this. A neutral water molecule in its vapor state has an electric dipole. So now this dipole, right? I say this is how to represent dipole, which is 6.2 times 10 raised to the power minus 30 coulombs per meter, right? I say how far apart? That's D. Do not forget dipole moment. I told you it is the charge multiplied by the distance. So if I'm looking for distance, I have dipole moment over charge. And my dipole moment is this value. Don't forget that it is the electron that is responsible for dipole moment or charge, right? So what's the charge of the electron? The charge of the electron is what? 1.6 times 10 raised to the power minus 19. So if I press my calculator, I should be I should be having 3.875 times 10 raised to the power minus 11 meters. So what's the next one? If the molecule is placed in an electric field, or to have an electric field, what is the maximum torque? What's our formula for torque? Torque is actually QED. Hope you have not forgotten. So what is Q? The electron, Abi. 10 raised to the power minus 19. What is E? It was given to us 1.5 times 10 raised to the power 4. And what was our distance from our calculation? 3.875 times 10 raised to the power minus 11. This is a whole lot of pressing of calculator. So if I press my calculator, oh my Jesus. So I'm having what? 9.3 times 10 raised to the power minus 26 Newton meter. Yeah. All right, so we want to do this. Example 4. We want to do example 4. Let's read. What are the magnitude and direction of the field? Okay, we are given R, right? Yes, R 2 centimeter. Change it to meter by dividing by 100, right? From a fixed point charge, so there is Q. Q is 3 times 10 raised to the power minus 10 coulombs. So I'm looking for E. We know E, right, is KQ over R squared. K is what? 9 times 10 raised to the power 9. Q is what? 3 times 10 raised to the power minus 10. And R is 0.02 squared. Now let's press our calculator. 9 times 10 raised to the power, I'm having 6750 Newton per coulomb. You get. So now the B part is now, how far away from the point charge does the field drop to 20% of its original value? Now look at what the B is trying to tell you. How far away, that's how far, right? With the field, it drop to 20% of the original E naught. Do you know what this statement means? You know, okay, let's write it. This is 20 over 100 as a lot of percentage, Abi. This of means times. What is E naught? Your initial. 6750. So when you press it, you are getting 1350 Newton per coulomb. That is the field. Now they are not asking you how far, meaning when the field is this. Meaning when the field is 20% of this, what is R? That's the meaning. So how do we get it? You know that E becomes KQ over R squared, and I have always told you. You can solve it like this, but for me, I feel the most effective way to solve it. That's right. I'm sorry. The most effective way to solve it is to make R subject of formula, meaning make what you are looking for subject of formula, so it becomes very easier to press the calculator. So it's just because of to press the calculator much easier. That's why you make R becomes what? KQ over E then squared. So if we substitute K 9 times 10 raised to the power 9, 3 times 10 raised to the power minus 10 over 1350. So R becomes what? 0.044 meter, which can, if I turn this to centimeter, I think I should be having 4.4 centimeter. So that is our calculation. So let's take example 5. Now, so let's read this our example. An electron is projected into a uniform electric field. So you have an electron projected into a uniform electric field of intensity 5000. So let's get a parameter. There is E to be 5000 Newton per coulombs. The direction of the electric field is vertically upward. So the direction of the electric field is vertically upward. The initial velocity of the electron is this. So I have velocity is 10 raised to the power 7 meter per second. And they ask me at an angle 30 degrees. So I have theta. to be 30 degrees above the horizontal. So they asked me to look for find the maximum distance the electron rises vertically above the initial elevation. So if you actually look at this question, you will notice that this question is a prototype of projectile motion. You get. So if you look at this, you are seeing basically projectile motion in which electric field is incorporated in it. So, and you must not forget your analysis in projectile motion that a projectile motion is a two-dimensional kind of motion which occur in the horizontal axis, which is the x-axis, and in the vertical axis, which is y-axis. And both motion, horizontal and vertical, they are independent of each other. You get it? And you must also understand your analysis of motion under gravity to be able to answer this problem correctly. Let's analyze. Now, in the analysis, find the maximum distance the electron rises vertically above the initial elevation. Do not forget that from this particular statement, you are looking for what is called maximum height. Now, what we are looking for, maximum height, right? And we understand that from projectile motion or motion under gravity, we know that v square is equals to u square plus 2gh. Now, because it is maximum height and there are two kinds of motion, we are using y and y, you get. And because it is vertically upward, we are using plus here. Now, this is motion under gravity, you get. But we are using y and y to indicate that we are talking about the vertical motion. G represents acceleration due to gravity, and h represents height. So because there is nothing like g here, we change this to what? A. Now, let's put ay to indicate vertical acceleration. All right, now this is it. Do not forget again that at maximum height, meaning when you get to maximum height, Abi, you must remember that v is equals to 0. You get. And our uy, which is our initial, this should be uy. You get. Our initial, which is uy, is what? This is not ui, this is u. Yeah. Now, how do we get our ui? Do not forget that you can resolve this into the vertical component, which is u sine theta. Is that true? So I have this, you get, at maximum height, v is equals to 0. To get your ui now, you have u sine what? Theta. Now, how do you get your ay? Now, do not forget that based on force, ma is equals to qe. Ma is mass times acceleration. Are you seeing it? QE is the same thing as force. So this is force is equal to force. But this is in kinetics, while this is in electric field. Are you getting it? So if you divide by m, ay becomes QE over m. So now I know this to be 0. I know this to be u sine theta. I know ay to be this. So let's substitute this and this and this into the equation, and let's see what we have. We have that v is 0, 0 squared is equals to uy is u square sine square theta, right? Plus 2. What is ay? QE over m times h. Are you seeing it? Now I want to make h subject of formula. Let's make h subject of formula. So collect like terms, I have 2qeh over m minus abi is equals to u square sine square theta. So divide both sides and make h subject. Now h becomes m u square sine square theta, then over minus 2qe. then we can now substitute our value. Now, it is not something that is complicated. Now, this is it. We are asked to look for maximum height. You get. So this is a formula that is used in equation of motion, which is motion under gravity, right? Now, at maximum height, we know that the velocity is zero. And how do I get ui? If u is 10 raised to power 7, you get, and theta is 30. To resolve the velocity in the vertical direction, it is u sine theta. Force is ma, force is 10 QE, because this question is a combination or a blend of both kinetics and electric field. So force, which is ma, is equal to QE. If I make a subject of formula, I will get this. So if I substitute this in my equation of motion, or motion under gravity rather, I will have something like this. Then if I make h subject of formula, I'm having this. Now let's substitute our parameter. What is the mass of the electron? What's the mass of the electron? We know it is 9.11 times 10 raised to power minus 31 times what is u? U is 10 raised to power 7 all squared times I have sine theta, which is sine 30 squared. Then everything over minus 2, right? You know, the charge of the electron is also negative. Do not forget. So I have minus 1.6 times 10 raised to power minus 19. And what is E is what? 5,000. So if I press my calculator, I will get H. So I'm getting H to be 0.0142 meters. So that is my H. Now let's go to the B part. And ask, after what horizontal distance does the electron leave the ground? You know that when you're doing projectile, right? Let me explain again. A projectile motion has two independent motion, which is horizontal and vertical. Are you getting it? The horizontal motion is a motion of uniform velocity along a straight path. It means that in the horizontal direction, the acceleration is zero, while the vertical motion is motion under gravity. So the resultant of these two motions is what gives you the trajectory of the equation. So you must have in mind that a projectile is doing two things at a particular time. It is moving in the horizontal direction with constant velocity, and is also moving in the vertical direction based on motion under gravity. And the two kinds of motion are independent of each other. Are you getting it? So now look at this. They say at what horizontal distance? Now I want to get the horizontal distance, which we usually call to be range. Is that clear? Does the electron leave the ground? Now, you know that S is equals to UT plus 1 over 2 AT squared. But the issue is that this is X, this is X, and this is X. And in the horizontal direction, AX is equals to what? 0. So I have S is equals to UX times T. Now, I can get UX. UX becomes U cos theta, right? Meaning this thing is something like this. Why have something like this? Here is 30 degrees. Here is U. So horizontal will be U cos theta, right? Vertical will be U sine theta. So that's how it works. Now, how do I get T? How do I get T? We have to go back to the motion under gravity, wherein we have V is equals to U plus AT. Now, hold this, just hold on. Let's use Y, Y, and Y. At maximum height, Vy is equals to what? 0. What is Uy? You know your Uy is U sine theta. And what is Ay? You know Ay is actually Q E over N. Seeing it? So if I substitute this here and make this subject of formula, then I have this is 0 is equals to U sine theta plus QE over MT. So if I make this subject of formula, T becomes T becomes what now? U sine theta over M U sine theta over Q E. You get. So we can put minus. Minus, we cancel minus because it's the electron. So that if I substitute that, T becomes what? What is M? 9.11 times 10 raised to power minus 31. What is U? U is 10 raised to power 7. Is this sine or cos? Okay, sine. I have sine 30 over Q is 1.6 times 10 raised to power minus 19, and E is 5,000. So if I press my calculator to get 5.694 times 10 raised to power minus 9 seconds. But do not forget that this time we calculated is just the time taken to reach maximum height. You get. So the total time of flight, which is T, will actually be 2 times T. So if I multiply this by 2, I should be having 1.13, yeah, times 10 raised to power, I think, minus 8 seconds. Now this is the time taken to travel. Horizontal distance, which is SS, is equals to UX times T. What is UX? UX is U cos theta. What is times T? T is your big T, the total time of flight. So U is 10 raised to power 7 cos 30 times 1.13 times 10 raised to power minus 8. The marker is not marking away again. All right, so if I press my calculator, 10 raised to, so I'm getting it to be 0.0979 meters. So actually, see, this is it. This is the formula to get horizontal distance. You get. So UX, you know it is U cos theta. Are you seeing it? When you resolve the velocity in the horizontal direction. Now the problem is T. So how do we get T? We go back to motion under gravity to the vertical direction. At maximum height, this becomes 0. UI is this, U sine theta. AY is this, right? So if I substitute and make T subject, I'll get this. If I put in my values, I'll get this. But the time I'm getting is the time taken to reach maximum height, because I made Vy to be 0. You know, at maximum height, Vy becomes 0. So the time I'm getting is the time taken to reach maximum height. So to get the total time of flight, do not forget to multiply it by 2. Then I will now come back to my original formula, which is Ux times T. Ux is this T. This T here represents the total time of flight. If I let me write it as big T, so you understand. As big T, yeah, T. It represents the total time of flight. You get. So if I multiply these two together, I will get this. So at this point, we come to the end of electric field. So what we must have in mind from part 1, part 2, and part 3 is that, first of all, the region of space around the charge where the electrostatic force of the charge can be felt is called the electric field. Is that clear? And you must understand that the strength of a field at a particular point is called the electric field intensity, which is defined as the force per unit charge at that particular point. You must also understand that a positive charge creates a field that radiates outward, while a negative charge creates a field that radiates inward. You must also understand that line of force is used to represent electric field, and that line of force has properties that you must be familiar with, which is the first one: line of force do not intersect. Number 2, the tangent at any point gives the direction of the field. Number 3, the density of the line of force gives the strength of the electric field. The closer the line, the stronger the field. The wider the line, the weaker the field. And you must also understand that line of force originates from the positive charge and terminates at the negative charge. You must now also understand the concept of dipole. What are dipole? You know, dipole is when dipole is created when two equal but opposite charge are separated by a distance. Not true. And the formula for dipole moment is that dipole moment is the charge multiplied by the distance. And when you put a dipole in an electric field, it experiences what is called rotational motion. And the force responsible for rotational motion is called torque. And torque formula is force times distance. So do have a nice day and God bless you.